Are you accepting people to call? Never mind.
Hallelujah.
Okay. All right.
Should we have this? I believe. Okay. Okay. Good afternoon, everybody. My name is Kofoworola, and I'll be presenting SQL Query Optimization today for our Cutty Talks. Thank you. So the content of the slide, what is SQL Query Optimization, SQL Query Optimization techniques, and some approaches to building up your query. What is SQL Query Optimization? Do you know that, this is a fun fact, do you know that SQL isn't just about writing queries? Yeah, most people forget that SQL is actually not about writing queries, but ensuring that the query is performant and it fits the context of what you are trying to work on is very vital when trying to write SQL queries. So things to consider when building your SQL queries. Number one, you have to know the amount of data in the database so as to know how to optimize your query in order to get an optimal result. You have to know the number of times needed to execute a particular query. You have to consider the goal or end result of a query, and also you have to have a basic amount of knowledge about your database so as to know how you can manipulate your ways and writing a more optimized query than someone that has no knowledge of the database at all. So what is SQL Query Optimization? SQL Query Optimization is a process of writing thoughtful queries to improve database performance by getting accurate and fast database results. So thoughtful was bolding because you have to consider these things in order to be able to write a thoughtful SQL query in order to improve the optimization. So SQL query optimization techniques. So I have the rule-based optimization, which is also the logic-based optimization, and the cost-based optimization. Should I? Okay, so for the rule-based optimization, it uses like a set of rules to determine how to execute a query. Take, for example, you are in like Cutter and Kush now, and if you want to run some particular queries to get some particular results, there are like some laid down rules we have to run a particular type of query. That's like the rule-based optimization. And then for cost-based optimization, if cost-based optimization comes up with the cheapest execution plan available for each SQL query. That is, the cheapest plan is the one that makes use of the least amount of resources like memory or space, then time basically, to get the desired result for a particular query basically. Then the approaches to building up, some approaches to building up your query. So I have just 3 approaches here. Number 1, retrieve only data you need. Number 2, limit your results. Then number 3, don't make queries more complex than they need be. So we'll be starting with retrieve only data you need. So performance might suffer if you are pulling up so much data and you end up not using half of that data. You end up not even using most of the data you pull up from the DB. Maybe you just need to get maybe ID and you are selecting all, especially if you are selecting from a table that has a lot of data. So it reduces execution time and then you end up not using the whole data you pulled up from. So take for example, these 2 queries. You are selecting all from programs. I'm selecting just program ID and program name from programs because you need just program ID and program names. If you select all from programs, you get other things like start dates, end dates, created at, cost, price, blah, 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 which you don't actually need in that particular scenario you want to use it for. But just filling up the 2 columns you need is like better. Then there's something called correlated subquery. Correlated subquery is a subquery that uses values from the outer query. So according to this example here, this example here, this one in brackets here is a correlated subquery. So it's running like another query here, but making use of applicant registration dot applicant ID, which is from outside here, to run the query. Basically, what this guy is just trying to do is select some columns from the applicant registration table, then join with the applicant table. So this subquery here is telling you that if I have a column in applicant registration table, and if it also has like an ID in the applicant, the same ID in the applicant table, that I should fetch it. But if that doesn't happen, then it should not. So instead of writing a correlated subquery, it will be better to use an inner join. So you can just write this, select your columns, and then you use an inner join to join the 2 tables together instead. Then another fun fact, do you know that the distinct operation increases execution time? Maybe most people don't know that the distinct operation on the SQL increases execution time, but it takes another amount of time to actually make sure that all the results you are getting from the DB is actually distinct. So I would just advise that you should only use distinct when it is necessary and not just use it anyhow. If you have another method of running the query and you will get the same result, you may want to check which one is more optimal, using the distinct or using the second method you are trying to use, basically. Then the second point is limit your results. So if you cannot filter down the amount of columns you are getting in a DB, you may want to limit the amount of results that you have. And also, it is good to limit the result set, but also limiting intermediate number of records within a query is also good. Like, it's even better safe to limit. You may want to be running some queries and doing some inner joins, inner joins, inner joins. So each join you are doing gets a whole lot of data together before you now start doing the and where before it filters the data down. So you may want to also try to limit the intermediate number of records within a particular query. So there's a cheat to actually doing that. So the cheat is to consider ordering the joint tables. Take, for example, if you notice that one table is considerably larger than another table. Take, for example, you want to do get, which example should I use? Registration. Okay, you want to do registration and applicant table. You want to join them together. Although maybe currently they are not so far in size from each other. But you know that as time goes on, you have more data on the registration table than on the applicant table. So you may want to select from the registration table first before you join, select from the, applicant table first before you join with the registration table, since the registration table is like going to be considerably larger than the applicant table in the future, even though they don't really have a lot of difference now. And then another example is, which other example? I think programs and programs topics. Yeah, that's another example that I can use here. Then, okay, for people that write E2, this is how we limit results. If you're going to be finding just one, or you can find first in Falcon. I just said to put this in. Then, important note, avoid running queries in a loop. Like it is a very, very bad thing to run queries in a loop. Apart from it, like affecting your query execution time and all, it also affects the project as a whole when you run a query inside a loop in a project. Then the last one is don't make queries more complex than they need be. So I'm going to talk about some operators basically here. The OR operator. So most times when we use the OR operator in a query, it is likely we are not using index or we're not making use of the index, and the OR operator actually reduces execution time. So digressing a bit, talking about indexes. So an index is a data structure that improves the speed of each data retrieved from the database. They are used to quickly locate data without having to search through all the old rows in the database every time the data table is actually accessed. A unique index creates separate data column without overlapping each other. Primary keys, and we have indexes on our foreign keys. In order to help do this and improve the speed of each data retrieved, so consider this query. You want to select all these columns from assessment table, but you want to select where user category is either active or user category is suspended. So it is better to actually use the in operator to do this instead of using the or operator, because even aside from increasing your execution time, it's actually cleaner to do it this way. Then the union operator. So I can remember there was a time when we were doing union in our Dufuna project on both. Anytime we are trying to get assessments for both enrolled and unenrolled applicants, we do union every time. But it feels like, it's not even it feels like, it's like we're writing the same query all over again, like from scratch. It's just that we are changing the table we are accessing, but we're writing the same query all over again. Because why? As at that time, the applicant registration table and applicant enrollment table, they are really similar. They are very, very similar. Like there's almost no difference between those tables and all. So it increases the execution time and it makes the project kind of slow in a way, even when the data inside the table is not even so much. So alternative to using the union operator is using a join operator. Now we kind of included the registration ID into the enrollment table, and we're able to use a join to make it more optimized and yeah, so there's this thing on the that you can run along with your query, explain and analyze. You can use the explain function and the analyze function, and it gives you the execution time for that. It gives you the execution time for the particular query that you run, except on some platform it doesn't work. I tried it on just gave me some other analysis instead. But I tried it on Postgre and I was able to get the execution time. Postgre, Postgres, sorry, Postgres, and I was able to get the execution time using the explain and analyze operations with running along with my query.
So you don't know what MySQL?
No, not MySQL. Like I am using dbeaver, so I tried it there. It worked, but it wasn't showing me the execution time I wanted to see. But it showed me other analysis. You could maybe try it on your Workbench or any other platform you use and see what it gives you.
I have a question.
Okay.
How do you base the size of a table? Do you base based on the records on the table form by by the columns in the table?
So most times I use records and I think of the future because I envision that this table in about 2 years time the records here would be more than this one or twice as much as this one. So I should use this one first, then maybe that one at the back. I use the column we are talking about. You can always reduce the amount of columns you get so as to make it more optimized. Is there another question?
What if you can't reduce the column?
Yeah, so if you can't reduce it, that's what I'm saying. If you can't reduce the column, you cannot limit your result. Just make sure that whatever you are doing, it is needed, like it is necessary, totally necessary. If it's not necessary, then don't do it. If you think there's another way of doing it, but you cannot, just try to do it if there's another way of doing it, even if it's going to take much of your time, you have a deadline, but then this is an optimized query. You know that you can write this query, but you don't have time to write it. It would just be better for you to try to write it and maybe tell your PM that I'm coming. I need to write an optimized query because anything you write, you may even forget that you've written something not too optimized, and then later in future it slows down the system and stuff like that. And I've had experience with this. You come back and then you work that thing over again. I think yesterday I was writing a particular query in my PR. It was 3 queries at the same time. I was hitting DB 3 times, and then one was like, I think you can redo this thing in a way that you're using just 1 query. And then I was like, it's not possible. And then I was like, let me try it. And then I went to my SQL terminal, and then I ran this, I wrote the query, and I used left joins. And what I'm using 3 queries to do, I was able to do it using just 1 query, and it was more optimized. And I felt happy. I was happy that I was able to do that. Even my advice is that we just try to make things optimized when we are doing things like this.
So I have comments and questions.
Okay.
First of all, well done.
Thank you.
You've done well. Okay, so first, second comment. Let me say that comment so you will know how far we are going.
Okay.
Second comment, it seems like you're getting a lot of reading from the screen.
Oh, okay.
So if we make the abstract people, we know all the time.
Oh, okay.
And also one way to help out is use your fonts to distinguish between code and
normal text.
It makes it easier for someone to see at a glance if the person is reading code or reading text. Okay, so it seems like just fill over rule-based optimization. Like just based on our rule and what is our rule and what?
No, like I said, for example, a particular company, say Qatar, just an example,
Okay.
that they have this laid down rule for writing some particular types of queries.
Example.
What's an example of a rule?
Let me think. Let me see. Okay. Take for example, what can I do? Sorry, I can't think of it very right now. My head. Okay, let me start of my example where I did the or operator and the where in operator. Say here now, we want to do that kind of a thing. We tell you that we want to check whether something is in a particular can I here. So we just said if you want to check whether there are some particular variables inside this particular column now that is the in you should use every single time. So every single time I want to do something like this, I always use where the column in the other data with the values I want to check, like some kind of data which determines how my query is going to be structured. Basically.
Okay. Then on slide 22.
Okay. Oh, this one.
Yes.
Okay.
Because what it means is
You're finding everything, then picking one.
picking the first one.
First one.
That is not there. There is no limiting in that.
Oh, I have to limit to one.
You have to limit to one. You don't specify the limit.
Then it picks
It
everything.
picks everything.
Then
You now pick the first one. So we pay limit and move on. It gives you one item.
Alright. The downside of using index, okay, I don't know the downside of using an index, but of course the upside is retrieving.
That's an example. I'm setting your question and answering it yourself.
Retrieving data fast. Like,
So there's a downside of using index.
okay.
If you're like having a lot of rights
Mm-hmm.
in DB,
Okay. Alright.
because basically, essentially, what you're doing in an index is you first of all put your entry in
Another place.
another place.
Enter
But it increases read time, but it reduces
right time.
So you have to check
Weigh the options.
Weigh your options. Then another way of enjoying your DB data is using views. Views.
Views.
With views, you are still probably using the same records recompiled.
Like catch it somewhere.
So normally if you create a table, every time you are writing, SQL compiles your query to run. But if you create a view, it's recompiled.
Oh.
But the downside is every time you need to add an extra view, you need to create a
View. So you may be forced to write.
So anyone asking the reports, generally people will tell you who's on the view. Anything that users will be taking a lot of time. Who's on the view? Whenever they will need, it is faster rather than hitting the file. But all in all, we have no way.
Thank you very much.
They did not change go.
I know.